Three, two, one. Hello, my name is Flavius Panescu, and this is my Physics 2212 Lab 4, Circuits and Capacitors. This is the table of contents. The purpose of this lab is to give students a better understanding of circuits, the different forms of circuits, and how circuits are used. The experiment observes the interaction of different types of circuits and the inner parts of the circuit, such as the resistors, batteries, and capacitors. We will use the formulas we were taught in class to calculate values such as resistance, capacitance, current, and voltage inside the circuit. Here are the fundamental physical principles. We have circuit rules such as node rule and loop rule. Node rule states that the current in equals the current out, and loop rule states that the total difference in voltage is equal to 0. Ohm's law states that the difference in voltage is equal to current times resistance. We also have conservation of energy and conservation of charge. We then have the formulas for resistors, capacitors, and batteries. We also must take into account ammeters and voltmeters, parallel circuits and series circuits, and linearization. Here are the models of the lab setup for part A. As you can see, we have a circuit with a current of 0.02 amperes at the first ammeter and the second ammeter. If we close the circuit, the voltage of the battery is 3 volts. The voltage at 0.47 is negative 0.959. The voltage at 0.100 is negative 2.041, and the total voltage of the loop is 0 volts. Supplemental questions. When you attach the voltmeter, you alter the circuit. Why doesn't the ammeter reading change? The voltmeter has a very high resistance. There's very little current flows through it. For the rest of the circuit, this current remains unchanged, and therefore the ammeter reading will stay the same. Now replace the voltmeter with an ammeter in parallel with the 100 ohm resistor. What happens to the current through the other ammeter? Why? Both ammeters will read 0.06 amperes because of the parallel circuit rules. Here is the resistance for each circuit element. What happens to a bulb when a battery is connected in a series RC circuit? The bulb becomes very bright, then slowly dims down. What happens to the bulb when it is connected in series to the charge capacitor? The bulb will once again become very bright and then slowly dim down. What happens to the current in the circuit in both of these scenarios? The current will start off very large and then have an exponential decay all the way to 0. Here's the time taken for capacitors to charge and then discharge with bulbs of varying resistance. Here's the lab data. And here's the graph for potential difference versus time. As you can see, it starts at a spike of around 8 volts and then exponentially decays all the way to 0. Here is the log of the potential difference versus time. Analysis. From the graphs, we can see that the slope is equal to negative 0.167. Using the formula for RC, which is negative 1 over slope, we find that RC is equal to 5.999. Now using the experimental details we were given, we see the RC is equal to 30 ohms times 0.2 Faraday. This is equal to 6. Discussion question 1. What if you were doing this lab in real life and use an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter, and how would it have affected the circuits you hooked it up to? An ideal ammeter has 0 resistance. However, in real life, the ammeter will have low resistance, but not 0. Therefore, the amount of current flowing through the circuit would slightly be decreased. What if you were doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. Our ideal model would predict that the capacitor would reach full charge instantly due to the assumption of no resistance. This prediction would not happen in real life because there is also a small amount of resistance in both the batteries and the wires. Therefore, the charge would be quick but not instant. In conclusion, we discovered the effects that different types of circuits have and learn about the importance and usefulness of circuits. Thank you.